Our last example that we're going to look at in this series is a gradient. And so what we know is that sometimes the amounts change. And so it's like an annuity, but it also has a factor that's increasing or decreasing over time. And so if you look at this drawing, you'll see that we're illustrating how the gradient is kind of uh, on top of our initial annuity. So if we look at these order of magnitude, we see that we have a gradient that starts in year 2, then we have double that gradient in year 3, triple that gradient in year 4, and so on and so forth, going through periods n. And the gradient is going to continue to increase over time as determined by the problem. But it can go up or down, and it can go by a single factor. It can go by a multiplication factor, so 3 times, 4 times, 5 times, or it can go by a percentage. So there's a couple different ways that gradients can be conveyed. And the gradient, it's very important to note that the gradient always starts in year 2. And when we calculate, we need to keep that in mind. Now, the gradient notation, if you were to do this by hand, starts with a very complex formula that has 1 plus I to the n minus 1 over 1I times 1 plus I to the n. This factor that you see right here is identical to our factors of find p given a, right? That's exactly the same as our p given a, because a gradient has a base of an annuity and then an increasing amount. So to take into account our increasing amount, we're going to take whatever that amount is, and we have this additional factor that we're subtracting from it. So we're going to find a present value given a gradient. And so what we have is we have the initial annuity amount, and we're subtracting from that a smaller amount that changes with a factor of n over 1 plus I to the n, and we multiply that by 1 over I. So you would have the gradient. So if it says a gradient of 400, that gradient would be 400. You would have your interest rates, and you would have your n's for the given time of that gradient. To write this in factor notation, we have g, p of g, I, n. Now, we can also convert a gradient to a uniform series. You see the derivation of the equation here. What have we taken out? Well, what we've done is we've taken out this factor here to find that annuity. Given a gradient, we'll have a gradient amount, and rather than this p given a factor that we find, we have just this 1 over I minus n times 1 plus I to the n minus 1. So that same factor down here. Remember, all of these are derived in your textbook if you want to see the full mathematical derivation of how you get these formulas from the base formulas of compound interest. All of these start with our simple compound interest formula. The factor notation of this is G, A of G, I percent, N. So what could this look like? We could look at it a couple different ways. We can see a gradient of $1,000 here, right? Starting in year 1, we have 5,000, then 6,000, 7,000, 8,000. So what this actually equals is an annuity of $5,000, because that's our starting amount. That's our very first amount that's given. And we remember that our annualized amounts, our A, start at the end of year 1. Our gradient is then going up by $1,000 each year, starting in year 2. So just like the previous slide, it showed the gradient happening in year 2. That's because this initial amount in year 1 is considered to be that baseline annuity amount. So year 1 is really representative of this baseline annuity, where the gradient, the G, doesn't start until year 2. And so we have a gradient of $1,000 starting in year 2. So 1,000, 2,000, 3,000, but we have an annuity starting in year 1 of $5,000. And it's really the sum of these two parts that help us to calculate the present of this amount. So we would break this equation into two pieces. If you're finding a present given a gradient, we actually start by finding the present given an annuity, and then we add the gradient to that. We do this the reverse way too. Here we have a gradient that's going down 8,000, 7,000, 6,000, 5,000. Our annuity is that initial $8,000. Our gradient is a negative number. It's a negative $1,000 each year. So in year 2, it's a negative 1,000. In year 3, it's a negative 2,000. In year 4, it's a negative 3,000. How do we solve for this? By subtracting. So I don't have to put negatives. I don't have to flip my arrows upside down. I just have to subtract. So in the previous example, I added the gradient to the baseline because it's going up. In this example, I'm subtracting the gradient from the baseline amount because it's going down. That's the key factor here working with our gradients. We're either going to be adding amounts or subtracting amounts from a baseline annuity. And the baseline annuity is the amount in year 1. So if we see that we are going to go from a baseline annuity to a lower value over time, we're subtracting. If we are going from a baseline annuity of $5,000 and increasing over time, we are adding. And we will do these examples and other examples in class in our worksheet today. Now remember, you have a quiz that's associated with the material that I went over in the second video posted to Blackboard that you need to complete prior to coming to class. And I will have the worksheets posted and we will go through the quiz answers and we will go through the results when you come in. I will also be posting a 4A homework that will go over the initial part of the homework that is homework 3, covering the first part of chapter 4. If you have any questions, please don't hesitate to ask or to come to my office hours.